Hey, my name is Calvin Zhang, and my project was on multiple style transfer with transformers. So I had the general question of how we can use AI to generate art, and I came across style transfer, which allows you to generate new art based on reference images. So I thought this was a really interesting idea, and I wanted to research this problem more deeply. So style transfer is a way in which two images are supplied, the content image and the style image. And the content image is the image that will be modified, and the style image is the image that will have its features extracted and imprinted onto the content image to create a new image. So as you can see, the Mona Lisa is the content image, and the Picasso is the style image, so it basically creates a Picasso stylized Mona Lisa. Style transfer has been around since 2017, so it isn't exactly a new concept, but traditional style transfer uses convolutional neural networks which face many problems. The first one is content leak, where over multiple iterations of style transfer, the original shape of the image will be completely lost. This is obviously not the desired outcome, as we want some traces of the original content image to remain. So as you can see in the first image, after 20 iterations, there's just no sign of the houses, so it's just completely gone. The second issue is the lack of semantics awareness. So this means that in convolutional neural network architecture, it doesn't actually understand the contents of the images. So that means in repetitive images such as a single photo duplicated 4 times or grass, the style transfer algorithm doesn't actually understand what's there, and it'll just transfer the shape of the style image instead of comprehension. The final issue is the lack of scale and variability. So with convolutional neural networks, if the style image and the content image are different resolutions, there will be a lot of random visual artifacts and the image will not be stylized properly. As shown in the image, the non-invariant images all have these strange vertical bars of color in the top row, and that shows that they haven't been stylized properly, like they are in the scale invariant one on the bottom. For implementation, I started by rerunning the experiments. So I took StyTR2 as my codebase and I forked it, and I tested all the claims that they solved the 3 problems with convolutional neural networks. First of all my images were of a different resolution, so that confirms that the algorithm is scale invariant. Next, I ran an image through the style transfer algorithm 20 times to see if the content was still there, and sure enough, it's still there. So that means that the content issue was solved, and as you can see, the pagoda is still clearly visible. Finally, to test content awareness, I duplicated an image 4 times and ran the style transfer through it. And as you can see, with each image, it's stylized exactly the same, so that means that the algorithm is aware of its surroundings. For my extension, I felt that there could be other ways to generate some interesting images, so I decided to add the option to do style transfer with multiple style images and select the weighting of each image. The idea of this is that it's going to be extracting features from multiple style images and blending them all together to create a more interesting image this way. So this was done by modifying the encoding and decoding methods in the transformers and changing the way that the style transfer model stylized the images by having individual weights of each style image decide the way that the features could be extracted. From this, I noticed that using multiple styles generates a really interesting blend of images. So from visual inspection, all of the images turned out to be somewhat interesting looking. And something I noticed during this was that when using a bunch of styles, it's hard to pick out the specific details of each style image, such as when doing 4 images with equivalent weighting, it's hard to tell what was originally Picasso. So this is why it's really important to have biased weighting towards which images you want to have their features stand out the most. And also, when you have weighting over 1, it can generate some really interesting images, but this comes at the cost of content loss, where you can tell in the third image that there's pretty much no Mona Lisa left, and it's very Starry Night influenced. Some take-home messages from this project is that style transfer is a really great way to generate artwork using neural networks, and some really interesting images can be generated. So while doing my extension, I noticed that there's a lot of challenges in balancing the content and style and how much content loss I'm willing to put up with through the weightings. And there's also a bunch of potential usages for style transfer, such as colorizing black and white images, converting people into cartoon styles, and visualizing certain aesthetics that would be used in interior design. So there's a lot of real artistic applications to this. Also, there's a lot of potential ethical issues. So like with all neural network projects trained on large data sets, there could be a problem with artists not getting credit for their contributions to the images that they generated through style transfer, and potential hidden plagiarism issues if the images are taken without consent and then they're stylized, and then it's hard to tell from there. So that concludes my presentation. Some future directions we can go into are segmented style transfer, where only specific parts of images are stylized, and audio, where the style of a different person's speech could be imprinted onto someone else's speech.